Paul, can we start the show now? I know we haven't done any slapstick yet, but I know you're getting very angry. But isn't usually that the shtick? No, that wasn't a trick. That is the shtick. Welcome to another episode of the Mighty Code Coder. My name is Rob Fitzgerald, here to make you great and help you innovate. In this episode, we are going to do some real AP questions from the previous year. I want to try to run you through a class composition model in setting up the question. Then answer the question, maybe even a couple of different ways. So in looking at last year's test, it is obvious that algorithms are a premium, but I must say writing a class and using constructors were in there too. So let's use Mr. Liu's UML models and you're going to be fine. Let's get going. All right, so I have a special presentation, a different mode, a different studio mode for you to do this. It's really nice. First time I'm using it, and so let's check it out. First, Paul, can you just be cool? All right. I don't know what's wrong with him. Him. I don't know what's wrong with him over there. All right, so let's switch over now. All right, so before we do this, I don't know how to do this. I feel like I should have an intro or some kind of a transition, segue, I think it's called. But I don't know what it is. So let's just switch over and show you what I got. Okay, so switching over. Okay, so this is my new Mighty Code Coder Studio piece. As you can see, it has an overhead. It's basically just an overhead. All right. So here is the exam, and this is the 2019 exam, and we just got done doing Mr. Liu's UML. So let's do some UMLs of this, and maybe this is a strategy you could use during the test. Okay. Some people will say, well, that's a little long, or I don't need to write this, but these questions are very long, and so you need to outline them. All right, so let's get going on that. All right, so these are instructions, how long it is. Now, your test is going to differ since this is 2020, and they're just doing free response questions. I don't know if they're going to change this or not. Okay, there probably still will be a number of 4 questions. Remember, those questions are going to have a part A and B, so really 8 questions. All right, and the percent of score is going to probably be 100. All right, so here is the first question. Okay, question number 1. And so on this side is the class that you have to break down and write some methods to. All right, so they give you the class. Okay, so it's AP class calendar, and they're giving you 5 methods. These are the methods we want to quickly jot down and outline so we know what's coming in and what's coming out. Okay, so I think we should do that now. Okay, if you remember, Mr. Liu, we talked about outlining this in the class composition model, and number 1 was, what is the name of the class? So this is class AP calendar, so we got to make sure you write that down. Okay, now we'll have a few of these outlines, so maybe this will help you get to the outline that you might have papers all over your desk and you're not sure which outline is which. That will give you the name of it. All right. 2 is going to be instance variables. Okay, and if you look at this one to start, I don't have any instance variables that I'm going to need from this breakdown, but I'll get that in the question. So let's actually go to number 3, which is the brain or the procedural input-output methods. Okay, so let's write those down. Remember, we just did this block thing like this. And remember, there's 5 of them, so you guys can kind of get those ready first. And you're going to use this whole side of the paper for it, so you can make it as big as you want. You don't have to worry about space. All right. And remember, this just gets your brain going in the right direction for this program. All right. And so the first one is leap year. All right. And then you have number of leap years. First day of year. Day of year. And the last one is day of week. All right, so without even knowing what this program even does, we're going to outline it. Okay, and that's why I did a different one up on the board in the previous video. I did a space alien ship or an alien. And just, you don't know what this class does yet. And so, but you can still outline it. All right, so the first one, as you can see, it is private static Boolean. So it is going to output a Boolean. So we're going to do this deal. And again, if you don't want to draw your little cylinders, you don't have to. And so it's a Boolean, and you're going to output this Boolean. So it doesn't really give you any ideas of what is going to be, but it just is leap year. So I could just name this leap year. And I'm not necessarily going to put this as an instance variable. I know this is going to be a local variable for sure. It's going to output from here. And it's going to be a true or false statement. Okay. All right. So we got that. Oh, and then if you look, what's coming in is an int year. All right. So you got to go here. And again, write this int, and it is going to be a year. Okay, so that's what's coming in. And I guess what we could have did is the year comes out and then it returns the year. Okay, so we could use the same variable, and we could make this an instance variable now if you wanted to. Okay, and then we'll have this just be, the output will be year. Okay, so is the year leap year or not? Okay, so we're going to use that same, we're going to use the local variable and the global variable to return things. All right, so we'll see if that works. Remember, we're just outlining this. We're kind of thinking that's how it's going to work, okay? So when we get to writing this, we want to be kind of quick and clear. All right, so the next one is number of leap years, and you can see it brings, it's going to return an int. Okay, so you see I'm already running out of room, so you probably want to give yourself enough room. And we're going to go ahead and return an int. So num leap year. This is a running total of how many leap years there is. So num leap year. All right. So there we go. And then if you look, it's bringing in year 1 and year 2. So we've got to actually create 2 of these cylinders here. They're both ints, and you're going to go year 1 and year 2. And those are coming in to that method. Okay, so you got 2 years coming in, and it's going to see how many leap years are between those 2 years. Now, the beautiful part about this is you don't have to write num leap years. Like I can already see in your head spinning. Oh my gosh, I got to try to figure out what numbers are. How do I figure out what num leap years is, or how do I figure out a leap year calendar? You don't have to. This does it, and that's what I want you to assume. If it says it returns number of leap years, you bring in 1 year, 1, 2, and it just does it. You don't have to know the algorithm inside at all. In fact, it's giving you a tip. You're going to actually implement this in part A. Okay, and it returns the value representing the day of the week for the first day of the year, where 0, actually, this is for this one. This is for this one. Returns the number of leap years between year 1 and 2, inclusive preconditions 0, 1, and 2. Okay, let's do the third one. First year. So it's going to kick out an int. Now you can see I really should have spaced this out better. Okay, so it returns an int. And that int could be first day of year. And so I'm going to go ahead and just call this first day. Okay. And I don't think I'm going to make that a instance variable yet, but it could be. It actually could be put up here. Okay. All right, so now let's go ahead and see out what it's going to actually. It's going to return an int, and then it's going to input an int year. Okay, so it brings in a year, and it kicks out the first day of that year. Again, the algorithm. You may or may not have to write this one. I forget if this is the one that actually is the one we write. It usually tells you if you're going to write it. And it says implementation not known. Okay. And so if it says implementation not known, that means you just assume it's going to give you that. If it says to be implemented, that means you're probably going to write it. All right. So there's the third one. Now let's do 4. Okay. 4 is going to kick out an int. And the int it's going to kick out is day of year. All right. So we could actually call that variable day of year. Again, I could make that an instance variable. I'm not sure I'm going to. So I'm leaving that blank for right now. And then it brings in 3, month, day, and year. All right, so this is kind of fun. So you just go 3 of these cylinders. And you can see you could scratch them in pretty quick. They're all ints, int, month, day, and year. All right, and then this last one is same thing. It's going to have an int coming in. And this is going to be day of week. And it is going to be 3 things again. All right, so there it is. You've already scratched it up that you kind of have this thing down. This whole page now could go away. You don't even need to refer back to it. Okay, so let's go ahead and put that up over here. And now here is question A, and I have my outline ready to go. All right. So the first thing is you're going to have to read this whole thing. A lot of people think they could skip right to this and figure it out, but I would suggest reading this whole thing to make sure you understand what they're asking. So write the static method number of leap years, which returns the number of leap years between year 1 and year 2 inclusive. In order to calculate this value, a helper method is provided for you, is leap year, and it returns true if it's a leap year, if it's false, if it doesn't. Okay, so that's what that one does. Complete the method num leap years below. You must use is leap year appropriately to get full credit, and they're going to actually give you the start of it. Okay, you're not going to get dinged if you put the curly brackets in or not. But here is the number of leap years. Okay, so they bring in 2, all right, from here to here. And so you know you're now going to probably go through a loop to loop through all the years they give you. All right, so let's start doing that now. That's the whole algorithm of it. So it's just going to be a for loop. Okay, and the difference with this for loop is where is the for loop going to start? Usually we go int I equals 0. Well, we're not going to start int I equals 0. We're going to start like the year is going to be, let's say we, instead of doing int I, we'll do int Y, the year. And that's going to start not at 0, but year 1. Okay, and then we're going to go Y is less than year 2. And then we're going to go Y plus plus. Okay, little curly and curly. Okay, so now as we're looping through that, we just have to say, is this a leap year? And we don't have to know how to calculate leap years, all right? So now let's just do an if statement. Okay, if, and remember they give us is leap year, okay, between, and then is leap year, you send in the year, okay? So remember over here, you send in the year. Okay, then it tells you if it's Boolean, true or false. So we're going to send in Y. Little curly bracket. Remember, you don't need the curly brackets if you only do one line, which is what I'm going to do. And then if it is, that means, remember, if it just says is leap year, if that's true, defaults to true. If it's not, it's going to kick out of this. And I didn't close this other side of this. By the way, you won't be marked off for missing those parentheses either. Okay, but if you want them to think you're a good programmer, then be a good programmer. All right, they won't look for little things to nick you on. All right, so then we're just going to say, and remember we have a coming out is going to be an integer, and number of leap years over here, we said we're going to call it num leap years. All right, so I'm going to go num leap years plus plus. So every time it's true, it's going to add 1 to num leap years. Okay, and then when we get done, of course, we have to return something. Remember, we got to return that int. So we're just going to go ahead and return num leap years. Oops. Okay, and that's it. So basically 1, 2, 3, 4 lines of code you had to write for that one, and that looks pretty good. All right, just loops through those, and is it a leap year? Yes, add 1. If not, that's it. So that's part A of number 1. Pretty good, right? Now, we're going to do number 2, and we're still going to use this over here. So you might want to go ahead and just take your piece of paper after you're done and move it somewhere. All right, and then go to B. So here's B. So you got to read this whole thing. This isn't even the question. The question's actually going to be on the next page. There it is. So you have to read all this, and you might want to skim ahead and try to get it, but I wouldn't. I would read all this, take your time, and really understand it. Now, if you take your time to understand what the question is, when you write it, it's going to be so quick. All right. So let's read it. Write the static method days of week, which returns the integer value representing the day of the week for a given date, month, day, or year. Okay, so you give the date, and 0 is the Sunday, 1's Monday, and so on. Okay, 6 denotes Saturday, for example. 2019 began on Tuesday, January 5th is the 5th day of 2019. As a result, Jan 5th fell on a Saturday, and the method called day of week would return 6. So basically, you're going to say, I'm going to give it a date, and I'm going to say what day it is, Sunday through Saturday. But I'm not going to return Sunday through Saturday. I'm going to return a 0 through 6, Sunday being 0. Okay, so you already know there's an offset there already. So -1 is coming up somewhere. All right. Here's another example they give you. Okay, so January 10th is a 10th day. As a result, 10/10 fell on Thursday, and the method recall returns a 4. Okay. All right, so we kind of get what's going on, okay? They give you these methods, first day of year, which is right here. They give you day of year, okay, which is right here. All right, here's all these methods. And of course, you've already diagrammed them over here, so you don't even need this, and you're through this thing already. Okay. All right, so let's now go on to the question. Okay, so I'm going to go and take this and put it somewhere. And now here is the question. Complete day of week below. You must use first day of year and day of year appropriately. Returns the values representing the day of the week for a given date. Okay, public static int day of week. This is, remember, this is going to return a 0 or a 0 through 6. All right, so this is really kind of beautiful. This is like functional programming. It's like almost where you don't even need to write any code. We know that you're going to have to get the first day of the year. Think about this for a second. You got to know what day it is, all right? And a weeks fall in 0 through 7. So you're going to probably think about using a mod. When you're trying to divide up something, you're going to probably use a mod in computer science or Java, all right? And it's going to be probably a mod 7 because every day of the week ends in 7, or there's 7 days in a week, all right? So wherever the day is, so let's say you're trying to do July 30th, okay, that day goes in and it's going to kick out what day of the week it is by first doing a mod, breaking it down to 7 so you can find out what week it is, all right? And then find out what day on the calendar that is total, okay? So if that was day 60, then you have to take 60 and run it through your methods here. However, the day starts not always on 1 or not always on Sundays. Maybe it starts on a Tuesday. So you have to add the day it starts to your total. All right. So let's think about this. Okay. The very first thing we have to get is the first day of the year. Okay. So if I get the first day of year, whatever year it is, let me start that over. Let's start with the first day of the year. And let's say it starts on the 2nd. On Tuesday. Okay, Tuesday is a 0, 1, 2. It's a 2. So we have to add some days here. All right, so first day of the year, and we're going to give it the year, and we take the year in here. Okay. So that should return that. So remember, first day of the year returns the first day. Okay, all we have to do is set it the year and it returns the first day. Boom, got it. Okay, don't have to do any algorithm at all. All right. Once we have the first day, now we have to add the day of the year. So like again, if the year started on Tuesday and that's a 2, now we add it to the day of the year. And remember, we have an algorithm to get the day of the year. Okay, and that is right here. So all we do is set the month, day, and year. We can get the day of the year. All right, so let's add the day of the year to the first day of the year because that would be like the 2 plus the 60, right? And so day of year. Okay, remember day of year takes in month, day, and year. Okay, so that'll give me, so let's say this gives you the 2, this gives you 60, okay? All right, but the problem with this is it's 62, but we said the first day starts with a 0. So we've got a -1, okay, to take 1 away. And then we're going to go ahead and mod that whole thing by 7. So we're going to take this, whole thing, and we're going to mod it. We're going to -1, and then we're going to mod it by 7. Okay, so what's that? 7. So that's really the algorithm. That's the whole algorithm for returning the day of the week. And so really we could set a variable to this and say output equals, but why don't we just return it? Okay, and so we could just return. I put that return way out there so for some reason. Oh, because I'm doing it backwards. Okay, return first day of year. And that's the answer. So that is the answer for number 2. It's one line of code. Okay. Again, you could break it off and try to get a variable to get this, get a variable to get this, you know, get a variable for the whole output, then return the output. But just do it like that, all in one line. Get the first day of the year, add it to the day of the year, -1 so that you're not on, you know, you got that offset of when the day starts. Mod it by 7, and that's what gives you number 1B. All right, pretty cool, right? All right, so that's it for that one. And yeah, it was pretty quick. So you one outline gave you 2 questions, and then you go to the next one. All right, this is number 2. All right, and it looks big. I mean, look at all this stuff it's giving you. Again, using Mr. Lou's, using a lot of Mr. Lou's UML, we could quickly get a UML for this thing and get it going. All right, so let's do it again. All right, so here we go. 1, the name of the class. So this is public class step tracker. Okay, getting that from here. Okay, they don't give you what it, you know, how to write. So I wrote the whole thing out, public class step tracker. And let's see if in the question they ask you, see the question asks you to write the complete class. So they're not giving you the stump code. I think they call it stump code. It may not be a stump code. What do we call that? I forget. But anyway, so they don't give it to you. So you got to write. So I wrote it right away because they didn't give it to me. All right. 2, they want instance variables. Okay. Now in this one, I think they give you instance variables. Okay. Let's read it. This question involves the implementation of a fitness tracking system that is represented by the step tracker class. A step tracker object is created with the parameter that defines the minimum number of steps that must be taken for the day to be considered active. Okay, so it's created with when it says the object is created with a parameter, now you got to start thinking constructor. Okay, so they're going to want you to write a constructor there with a parameter that comes in. So a single argument constructor. The step tracker class provides a constructor and the following methods. All right, so there's add daily steps, active days, and average steps. All right, so let's go ahead and actually write those out first. So I'm going to give myself some room this time. Give yourself some room on these. The more white space you give it, the more your brain feels how easy it is to read. Okay, so this is white space. All right, so this is going to be add daily steps. This is going to be active days. And this is going to be average steps. All right, and let's see what this is. This accumulates information about steps in readings taken once per day. So it accumulates. So it's just going to take it in. So it's like a setter, right? So even though it's not a setter, it's accumulating. So every time you call it, it adds to something. All right, so we're going to go ahead and send in an int, and it's going to be num steps. I'm going to call it. Remember, I'm making up these names, num steps. Okay, and num steps could be a global variable, an instance variable. Okay. Now this is important to do this outline with the instance variables, because the instance variables, you're going to write a class here. So you're going to need to instantiate declare all your instance variables. So you need to try to get these down. Okay, so you're going to need a num steps that comes in. And so it accumulates that. So it comes in. But that word accumulate is just going to mean nothing comes out. So we're not going to have any output here. So it just brings in num steps and gives you the add, and it keeps adding the daily steps. You could almost start seeing the algorithm for this. It's going to be daily steps plus, okay? Or num steps plus, whatever num steps is, okay? All right, so then the next one is active days, which returns the number of active days. So we're going to come out here, and you're going to return int, and it's going to be active days. And so, yeah, this could be a global. All right, there you go. Active days, pretty nice. Let's do the third one. Average steps, which returns the average number of steps per day calculated by dividing the number of total. Okay, so that's an algorithm you need, but all we're trying to do really is figure out what this thing takes. So it looks like it returns the average number of steps per day, all right? And that's it. Okay, so nothing comes into it. So let's just go ahead and, yeah, just something comes out of it here. Working on my arrow here. Okay, and so what comes out is going to be, now remember, it's going to be the average of number of steps. So when you divide it, it's probably going to be a double. Probably not going to be a whole number. So we're going to call this average steps. Okay, and I'm probably going to just go ahead and declare that right here. All right, so we have some other things. I feel like we're going to need some more variables up here, but let's read it and see. All right, the following table contains sample code for the sequence. So you could see they instantiate it with 1,000. Active days takes, sends nothing in, returns 0. So it returns an int. Nothing comes in, returns a double. Okay, nothing. Okay, sends 9,000 in, nothing comes out. 5,000, nothing comes out. So this is what you're looking at. You're looking at these parentheses. Nothing comes in, 0 comes out, nothing comes in, 7,000 comes out, or an integer double. All right, so that's what you're starting to see. So if you want to see how these all work and see if you got it right, you really could look up here. Look at average steps, brings nothing in, and it sends out a double. Okay, so you got it set up perfectly. Okay, so let's go ahead and turn the page. If you wanted to, you could write void in here. These are voids. You could actually even put int and then double, whatever. All right, so you could write that out, but I don't know if you'll need it. So I think with Mr. Lou's UML, you're set. All right, so here it is. This is the question. Write a complete step tracker class, including the constructor and any required instance variables and methods. Your implementation must meet all specifications. So you're just writing this class. Okay, so big one, biggie for you. All right, so we'll start with the name. Public class step tracker. Okay, and we'll do the opening curly and the closing curly here, giving us enough room. I'm going to really try to give us some room here. Just go ahead and give yourself room. Remember, you're not going to be penalized if you don't get your curlies done, so it doesn't matter where you put them, if you even put them. All right, so you have to write all these. All right, so your instance variables to start, all right, are going to be the first thing you do. So let's go public int num steps. And I'm just taking it right from here. All right, public int active days. Okay, and if I remember right, if I bring this back, and now I'm thinking about it, and this active days, if I remember right, it says object is created with a parameter that defines the minimum number of steps that must be taken. So we probably should make this an instant variable, min steps. Okay, so I'm going to go up here and go int min steps. Therefore, I got to put it over here. Public int min steps. So you have to have a minimum amount of steps to have active days. Okay, so that looks pretty good. And if you come back to here and you go to average step, average daily step, active days, average steps, average daily steps, active days. I feel like I need one more. I feel like I need a num days. So the number of days that I actually active day num days, because if you look at average steps, which returns the average number of steps per day calculated by dividing the total number of steps taken by the number of days tracked. So this number of days tracked, I feel like I got to keep track of that. Okay, so I'm probably going to go over here and add another instance variable, okay, called num days. Okay, I could call it num days tracked, I call it whatever, but that sounds good. And then let's go ahead and declare that here. All right, now if you don't get all these done to begin with, when you start writing your code, you're going to find you need them and then you could add them. Okay, if you read carefully, you'll see you're going to need some of these to begin with, you know, and you could underline certain things you know you're going to need. Okay, number of steps taken, you know, number of days, and then make sure they're over here. All right, so I think we got the instance variables down. Now, after the instance variable, okay, remember the big three instance variables, the brain, which is the constructor. So let's now do the constructor. All right, remember the constructor needed to have created with a parameter that defines the minimum number of steps. All right, so we have the minimum number of steps here. Get these out of the way. All right. And then let's go ahead and go, this is how to define your constructor. Same name as the file, same name as the class. Okay, remember it's going to take in the minimum number of steps, which we created over here. Okay, so we're going to go int min steps. Okay, now in your constructor, you got to make sure you instantiate things. All right, so let's go ahead and set the min number of steps. Min steps equal to min steps. All right. There you go. All right, that looks pretty good. And then we could declare the rest of them and set them to 0. So let's go ahead and do that now. Let's go active days equals num steps equals num days equals 0, kind of a shortcut to declare all three of those without laying them out like this. Now, if you're not comfortable with that type of technology or that terminology, go ahead and just just list them like this and set them equal to 0, or you can set them equal up here, up to 0 up here. Okay. All right. All right, so we got the instance variable done and the constructor. Now, I would tell you to go ahead and do a to-string method if this was a normal class or you're writing a program. But since it's the AP test and they're not asking you to do a to-string method, I would not do a to-string method here. Okay, and now I would just do the brain. Okay, or you could write a to-string method if you have time. All right, so let's go ahead and write these. All right, so the first one they want you to write is. Let's go ahead and write, you could write them in any number, but I figure we could get the daily steps first. And I'm doing that probably because, I don't know, I want to write this one right here that has the 9,000. All right, so let's get those in first. So I'm going to go public void add daily steps. And remember, you bring in int num steps. Okay. And you get that from right here. See, you're just writing this. So you can write it very quick. It's a void because there's nothing here, so it's a void. And that's why you come in and write a void here. So you got that set. And now let's open up these brackets and write this one real quick. So what would I have to do to get daily steps? Okay, all I'd have to do is make sure I add 1 to num steps, or the number of steps coming in. All right, so the num steps right here are num steps. That's coming in. Now, how do I keep adding them? Well, remember, you could use the global variable this dot num steps. Plus equals. Okay, so that'll keep adding that num steps up. It'll keep a running count. And then if you remember, this add daily steps is not going to return anything. It's just keeping a return. It's just going to keep it a number. So we really don't have to add anything more than that. Okay. Now, if we want to keep steps of active days only, all right, and you could go in here and add a, num days plus. So every time you call this, let's bring this back. So every time you call this here, so you're keeping a accumulation, all right, you have to actually add 1 to num days. Okay, so the number of days, because we're going to need that calculation, this average steps. All right, but it did say num days are only of the active days. Okay, so average steps, which return the average number of days, steps per day, calculated by dividing the total number of steps taken by the number of days tracked. And the number of days tracked is the object is created with a parameter that defines the minimum number of steps that must be taken for the day to be considered active. Okay, so it can't be one that you didn't have enough steps. So you got to maybe write a little if statement here. Okay, so let's see if that day actually was an active day, and we'll add that. So these are number of days. Let's do the actual active days. So if num steps is greater or equal to the minimum num steps, then we could add one to active days. Okay, now you know why we got to declare this as a global variable, because we want to go ahead and accumulate up there. All right, so now we added to the total number of days tracked, and then only the ones that have the right enough steps. Okay, now we just have one more to do, and we're just going to go public. Now remember, this one is going to have a return type of a double. You could write this almost without even knowing the question. Stub. I think they call it a stub. You could write the stub. Sorry, I forgot what they used to call that. So let's call this average steps. Okay. And remember, it has to have this. Do I do that? Yeah, I did. Okay. So remember, it's not bringing anything in, so it's empty. Curly bracket, and now this is the average. And they told us right here how to calculate the average. Okay, the average was, returns the average number of steps per day calculated by dividing the number of steps taken by the numbers of days tracked. All right, so this is one's really easy. So we're just going to return num steps, okay, and by num days. But if you look, the num steps and the num days are integers, and it says it returns a double. So we've got to cast one of these as a double, so it returns a double. So I'm going to go type a double here. Okay, that means return num steps by a double. So once you divide by a double, it will return a double. So now I could return. Okay, and that's it. All right, so there is your steps tracker with Mr. Lou's unit outline. Okay, and no problems. All right, that's an entire class we wrote there. All right, so this is getting a little bit long. I'm going to stop it right there, and it goes on to number 3, and let's bring in 3 and 4 in another video. But for right now, let's switch back over and see if I could show you a couple more things. Okay, and switch it to 1. Hey there. Okay, computer went to sleep. All right. And yeah, so got to get everything back into kilter here. This is new studio. How do you like the new studio? Okay, new studio for overhead. That's not new teaching. Either is a whiteboard. We've had these things around forever, but to put them all in one studio, it's kind of nice. All right, so the one last thing I might show you, that these all have a rubric, and so you might say, well, do I have to do a toString method in that number 2? What are they giving credit for? And they have something called a scoring guideline, AP scoring guideline. And so I'd like to show you that here. And so if I go here, and then I switch back over here. Oops, sorry. I'm here. New lab, new studio. All right. So here's the scoring guideline. And if you look at the scoring guidelines, it gives you what you're going to get point penalized on and what you're going to have a penalty for. So take a look at those. And then it also goes over, here's part A. You're going to get a point for initializing a numeric variable, loops through each necessary year in the range, calls for is leap year, updates count based result on is leap year, and returns count of leap years. Okay, so you can see what they're going to give you. Part B, first day of year, calls day of year, calculates the value, returns this. And then they talk about static methods called with this. Okay, you get minus if you're using this on the static method, but don't worry about it. You don't do it. We didn't do that. We didn't use the static method. We didn't use this called. All right, and there's some more scoring guidelines for number 1. you could go over those and see, where you're going to get points taken off and where you're going to get points. All right, this is actually what the graders use to grade your stuff. And then here is part, this is actually the code for it. Okay, now remember we did this all in one line. Okay, you could do it this way. This looks pretty close to what we did. Yep, look at that. Year one equals year one. All right, so you could download this. Okay, here's the steps tracker. Okay, declares all private instance variables, constructor, and then three variables. No toString method. So that shows you that you don't have to write the toString method. Stay exactly with what they told you to write. All right, and then they give, this is actually what the score is going to use. You could look at it to see how they go about it, see how they give you points off in case you don't do certain things. All right, and this is all available to you online. Okay, so I'll switch back over. Make sure you look that up, but that is going to be your AP Computer Science A scoring guidelines. Find it online. Okay, take a look at it. And I'm just not very smooth with this. Put that over there. Okay, I hope you like that. Pretty awesome. Okay, so hopefully this did what we were intended to do. That does it for this episode. Hope that you enjoyed it. Remember, always trying to make you great and help you innovate. So until next time, Paul, yeah, what? Yeah, yes. And if they have questions, they can leave comments below or go to the website at www.themightycodecoder.com or find me on Twitter at mightycodecoder. Also, that's my email. Okay, and my students know you can get a hold of me in Google Classroom. All right, thank you for watching.